All right, so today's session is on weather data in ARM, and really we'll break it up into two main components, two main features really of ARM. The first step is, of course, to bring in the weather data, and we'll really just show the workflow for taking a custom weather station data, whatever format you may have, and creating a connection in ARM. So ARM can recognize and understand how your weather data is formatted, so then it can automatically import the information from your CSV weather data into your trials. Then we'll take that data that we've imported and visualize it. We have a weather graphing tool that's been added in the last year or so to kind of have some visualization of the daily weather that is in the ARM trial. So we'll start with the weather connection. And really, as I said, we're really working with whatever format of data you might have. And so I have an example here. It's off screen. Let me open it in Excel. And it's just an example output, really any sort of weather station, weather data that you may be able to acquire will all lend itself to use in ARM. And so here's just a real simple example. All my dates are in 2017, but they have different headings that definitely don't and won't match the headings in ARM. They probably won't be in the same order, et cetera, et cetera. And we'll train ARM to understand the format of this spreadsheet to be able to import the information that we need into our ARM trial. And so this setup is a one-time setup for each format that you may have for your CSV file. So once I train ARM to understand this setup from whatever weather station I pulled this from, then I'll be able to use this again and again for all of my trials this year, for all of my trials next year. As long as this format stays the same from my weather station source, then I'll be able to use it again and again. So there's some great power here to taking a little time to set it up. And then the reuse is very, very powerful. So, and I opened this in Excel, but the format that we are using is CSV. So that's short for comma separated value. It's a very common, just no formatting spreadsheet is essentially what it creates. So if you do have a file that's in an Excel, the XLS or XLSX, then Excel can just do a save as, and you can create a CSV pretty easily. So that's about the one requirement really for that file is just the format being saved in a CSV. So I have a trial open here that we will utilize to set up the connection and then bring in the data. So kind of the first one we'll demonstrate is in your site description on the weather section, we have the very large weather table. And this is really designed for daily weather totals for a whole host of fields. We have a lot of different information, and there's even more that's being hidden currently as well that we can bring in for our trials. So we can, under the Tools menu, import weather data, and we will import the data into this current trial. And so to start with, we select a connection. And so what we will do today is set up a custom connection. And so this will start the wizard here where we fill in the settings to define this connection that ARM will then save and recognize going forward. And so we'll just kind of work through this process. The connection name is whatever you want to call this. Typically I would, probably have the name of your weather source So I'm just going to say it's called WSource is the brand that provides me my data. And then you'll also want to note whether it's daily or hourly. And that ties in with this type here because we do have, so the daily weather is this weather table. If we have time, we may show the application weather, and that can be hourly, excuse me, the hourly data, because we can hook up to the application codes. And if you have start times and end times for your applications, then you could feed in an hourly weather spreadsheet, and ARM can look up it hour by hour to find the correct hours of weather to put into your application section as well. I don't know if we'll have time to show all of that, but that's really the two options here. So I like to try to include that bit in the connection name, since there's really the two types of weather that you might be looking at. The source code that matches up with the column in the weather table called source. So you can specify if it's a local weather station, things like that, if you want the source column to be filled in when you do the import. So now the next section is referring to the date and time settings of the CSV file. So of the document that you have. So it might not necessarily match the settings that you have on your computer. And so we kind of wanted to make sure that there was that flexibility. And so if I pull my spreadsheet over again, we can see the date here. The time settings don't matter doing the daily weather. I don't have any time here, but certainly the hourly, of course, is then very important. So I will want to set up my date settings to match what is saved in the file. So in that case, we had month as a number, day as the number, obviously, and then the year. The separator was a slash, and then the 4-digit year was what was used. Again, time format not very used here in this case, but I think it would be 12 hours, kind of be relevant for the daily weather in this case. Next set of options really is for the CSV file itself. So this wouldn't be something you would be able to tell if you opened the file in Excel, but if you opened it in Notepad, you would be able to tell. And typically this would probably match your Windows settings, but maybe not always. And so it's really the delimiter is the character that separates your values to make the list, and then the decimal, of course, when you have a numeric value, what is used as a decimal. And so here in the US, comma and period are used, but in a lot of other places around the world, those two would actually be switched. So we just had that option to make sure it matches what your file has for options. Next is the set of options for the default units. So, in our spreadsheet, we actually didn't have any, a column of data that had the units listed explicitly. So a lot of times these outputs kind of just assume that you're talking in inches or centimeters or degrees. So this is the way to kind of define that for whatever types of information you may be importing. So for us here, the precipitation, I believe, was an inch, using the US conventions here. So we probably have Fahrenheit for the temperature, and wind speed was miles per hour. Again, just setting that to whatever you would use. I don't have any short wave radiation that I'm going to be importing, so I can leave that blank. I don't need that. So that's step one, to just kind of get the overall settings of the spreadsheet. The second step here is the data headers. So this is how ARM will recognize the data headers and know what columns of information we have in the spreadsheet. So we could either hand type and the first column was date, and then the next one was temperature high, but it was abbreviated this way. Kind of error prone. So really the recommended way, instead of typing each column by hand, is to actually feed ARM an example file to show what the headings look like. So that's what I'm going to do here, is press the button to read headers from CSV. And note that we're not actually importing data right now. We're just giving it an example of our output, so it can read and find the heading information and bring that in. So here I've got my daily weather export. And if you recall, the headings weren't actually in the very first row of the spreadsheet. They were in row number 3. So here I'll change this to 3, and now ARM brings in all of those headings. So now it will know this is what my spreadsheet will look like. You'll find all the headings in this order in that output. So that's really the custom connection here of what is in our output file that we're getting from our weather source. So when I say okay, it has all of those settings and it's given us that new connection that ARM will remember and save. So the final component to set this up is to map the information we have in the spreadsheet with where we want that information to go within ARM. So for the date, of course, we want to match up with date. That lines up pretty simply. Temperature high, we can go through and say that we would want to be our max temperature. The time, so my spreadsheet had like a time when our high temperature was reached. We don't have anything like that in ARM, and maybe I'm not interested in it anyway. I can just leave that blank. You don't have to have a selection for each and every row. So we're just defining which information should be brought in, and then where that information should go into. So an average temp, this is our relative humidity, and I think we only have an average humidity in ARM. So let's see where that is at. Temperature, but we have min, max, and average. I'll take the short route and just do the average. Maybe that's all I ever use anyway. Rainfall would be precipitation. And so once you finish selecting that, there's a little save button just to, again, save those settings into this connection name. So that is really the setup for the connection itself. And that really just needs to be done once for the formatted output that you have here. In our case, our daily export CSV file. And this connection file is actually saved onto your computer. So if you wanted to share that file with others, you can have one person who's the weather guru, if you will, that gets these connections set up, and then you can simply share that file with everyone else that's using ARM in your group. And now everyone can just load that connection from the list and be able to proceed with that. So now we'll utilize this connection to actually import information into this trial I have open right now. And so we have a few options to do that, just depending on what data we want to bring in. We can either import all of the weather data from the file. So that would be the entire date range of whatever is in that output. So if your weather source, you specifically handpicked a date range that you care about, you could just bring it all in then to this trial, and that would work great. If you already had your dates filled in, maybe you already filled this in with some irrigation totals or some other information, so this table is already partially filled in with the dates that you care about, then you could also just import weather data to blank weather fields. So this will just fill in anything that's missing without adding more rows. Finally, you can import weather for a particular range. So, maybe your output file has all of 2021, to date, and we really don't need all of that. We just want a specific range that pertains to this trial. That would be this selection. And so the from and the to actually will be populated automatically from your trial. And so it will read like the start date and the end date. There's a few different things it can read depending on what all is filled in. If this isn't marked as final yet, maybe it's the last application date. There's a few fallbacks ARM can do to kind of figure out the most logical date range of when did this trial start and when did it finish, or when was the last thing that occurred in the trial. And in my case, my example is pretty narrow. There's not a whole lot of dates in this example. So it's probably not terribly realistic. That's between November and December, but that's what we're going to use in this case. You can also add, kind of tack on a few days before or after this range. So that can be kind of helpful if you want to make sure to include, 2 weeks ahead of time, before the trial started, or another week after, or 4 days after the trial ended. Whatever these dates fill in as, you can certainly tack on more days if you want. As I said, my output is very, very small examples, so I'm going to stick just to these dates that I have here. And so now, once we decide what we want to bring in, then we can say OK, and we will be prompted to select the weather source with the data that we want to bring in. And in this case, I'm going to choose the very same file that I used before. So now it is importing that weather information. And we can see that we were successful. And so now we have, for our date range, we have a row in this table for each day in our range. And we have brought in, let me show any hidden columns with information. We brought in the precipitation with the default unit we chose, all of those temperature fields with the default unit, and also our average humidity. So those were all brought in because we defined them. And then there's our source that we selected as well. And then just note that the moisture total, that is kind of automatically calculated by adding the precipitation and the irrigation. So typically when you're setting up your connection, you would put in rainfall into the precipitation column. The ARM will fill in your moisture total automatically. You don't need to have kind of a second go around to fill in the moisture total. So that is the process for bringing in the weather data. The nice thing is, as I said, this connection, it can be reused. So now with the next trial, you could open up the next trial and use the same, let's just do it here, import weather data to that trial. And then you would just select your connection that you just set up. And then you can choose your date range and import the data. And so it's much faster once you've set it up the first time. Next year will be the same thing. If you have that same output for your weather information, same thing, you can use the very same source. Or if you need to tweak it a little bit, you could load this one and then change the headers if something moved around or whatever. Real quickly, I do want to show just real briefly the application import. So we talked about that just a little bit. I won't set up the entire connection, but let's do tools, import weather data. And instead of setting up the whole connection again, I'm just going to use one I've set up before. And I'll just show your settings real briefly, really the same idea. The key difference is this type is application weather. And really we're working with hourly data instead. And you'll still load in the CSV headers, I should say, but the key is that this dropdown will be different because this is application weather. So now we are picking fields in the application description where all of these weather related fields for our different applications. And so as I mentioned, ARM will look up the date and the time, hour by hour, to fill in this information specifically for those spots that you have in your applications. So there is really no selection of what to bring in or not. ARM will handle that for us. It's very specific selection of what you have in the start and stop times. And if you don't have like a stop time, that's fine. If it's blank, just it won't fill in the stop information in the weather. So let's import, and here I have, it's a separate file. It's an hourly export instead. And so it read application weather. As we said, for each time, it went and looked up the information that it could find, and there was an air temperature, relative humidity, and the velocity at all these different times. And so it's filled in all of those details for all of the applications in this trial. And maybe I'll just open that hourly export real briefly, just to see the difference here. Open with Excel. Oops. So here we actually have multiple rows for each day, and it's at each hour. And not quite as much information, but we probably didn't need all of that information for the application. And so ARM really just found just the pieces of information we need to fill in that application section. So that is the connection to your weather spreadsheets, and you can make one for each of them if you work with several different types of weather stations. Maybe for different trial sites, there's different stations. Pretty easy just to set up the connection once for each type that you have. Give it a name so it's very clear which one that goes with. And then you can utilize the whole host, the whole library of them. As you saw, I had quite a few that I've set up over time. And the file, I guess, is probably noteworthy just to point out where that file is saved if you did want to save to others. Typically, most of the files get saved to the GDM def folder, but this is one example where it's actually one level up. So it'll actually be in your ARM def folder. I'll search by date modified, and there's the one we just created. So it'll have a WMAP, short for weather mapping, is the extension on that file. So this would be one I could share with a colleague pretty easily. I would just send to an email and mail to send it to my colleagues. They can all save it into their ARM def folder and be able to utilize that connection. All right, so that is the connection. I guess I'll just leave a moment in case anyone has any questions, and then we'll transition over to the kind of the second half of this, is taking our daily weather and visualizing it. Close these spreadsheets I had open, and we can toggle over to the other. I'm actually going to open a separate trial just since, as we saw, there wasn't a whole lot of data in this example. So I'm going to switch over to another trial. to show the weather graphing. All right, so here's an example trial. A little bit more extensive. I've got data from April all the way till October. So we got a lot of data here to, that's been imported. And so we really want to be able to maybe visualize this information, kind of get a sense of maybe what happened weather-wise in this trial while everything was going on with this trial. And so you can either press this shortcut button here for our weather conditions. We have our little graph symbol. Or under graph, you can also graph the weather data. We will start off with a new weather graph. So the goal here, what we will be doing is taking all of this information, this daily weather, and plotting kind of whatever we would like to see really onto some graphs that will be plotted across time. So we've got a lot of options, and we'll build slowly. So just looking at this first graph here, we will actually have the ability to add up to 4 graphs on the screen at once. So that's why there's a lot of options here, but really we'll just focus on this first box here, because that will define the first graph that we create. And so we can choose the data series is what data do we want to graph? What information do we want to see? So maybe I'll just start with the average temperature. So we can see kind of our daily temperature, how that fluctuates throughout the season. And so there's a few different types. Maybe we'll just start with a simple line graph in this case. And so we'll just, I think everything else as default works pretty nice for now here. What's really great about these graphs is we actually can choose more than one piece of information to include on the same graph. So we could even bring in something totally unrelated in the fact that average temperature would be, degrees Fahrenheit in our case. We can actually bring in precipitation information as well and just use the right y-axis. So now we'll actually have 2 different data sets that have different ranges of information, all on the same graph. And you'll see we can just choose the labels. They kind of got auto-populated for us. If we want to change something about those, how those axes are labeled, that would work just fine as well. So we'll have on the left axis is temperature and the right is precipitation. We'll start with just the first graph, and we'll be able to come back and forth and continue to build on some other options and other graphs. So if we say okay, now we're presented with our graph, and you can see kind of how we were able to do the 2 different pieces of information. Temperature is the blue average temperature. So that's going to range between 30 and 70, probably gets us up to 80 here in the middle of July. And so we have the blue line is plotting that average temperature at each day. Now on the right axis, we have the precipitation in inches, and you can see that being precipitation kind of hit or miss, spikes between 0 and just short of 2 inches. Some other features for this graph, we do plot out kind of important dates of the trial. So here looks like it would be in April for us, we had application A, and then application B was 1st of June, and then the application C was in July, and then we also have the completion date. So just kind of, significant dates of the trial that might matter as we look at, how much precipitation occurred, or wow, we applied on a very cold day. Was that first application? I wonder if that had any role in what we ended up seeing in the treatment results. And so just a way to kind of visualize important critical information, critical steps, events, I should say, in the trial. We also have a slider, and right now with just one graph, it's really useful primarily just to focus in on the weather summary on the right here. So we can select, maybe we want to see information from June until September. Oops, I can drag this slider around too. So let's say a 3-month window. I keep missing that slider, sorry. 3-month window from June to September. Then we actually get some totals. I guess I should say some minimum, maximum, and average for that range of data. In this case, it's of the average temps. Same thing for the precipitation then, the smallest value, the most rain you got in any given day in that range. And then on average, we got, 14/100ths of an inch in that date range. And then we could slide it over if we want and see the next, July to October and get that summary as well. So we'll see that this slider again when we start to add more graphs. It'll be pretty helpful to visualize the other graphs as well. So I do have a question. Is it possible to analyze maybe more than one trial's weather at a time, maybe with ST? So that would be a pretty cool feature. We do not currently have any sort of analysis or visualization with weather in ST. So ST currently is pretty focused on the assessment data and combining that. But certainly that would be very, very interesting. And kind of leads me to one of my final points I like to part with when showing this feature is if you have any sort of examples, if there's anything that you do by hand to visualize weather data, we're very, very interested in ideas for more visualization of weather data in ARM. A few years back, it wasn't too many years ago, really, this weather table was very brief. And so we really focused some development on expanding the table. So we really have the ability to document a lot of different information about what happened weather-wise in a trial. And then once we got that done, the next step was, well, how are we going to visualize? Now we need to do something with the data. And so this weather graphing, as I said, is pretty new, but certainly wouldn't have to be the end of the line for us as far as visualizing the weather data. If there's other things done out in the industry that would be really great if ARM would do, we'd love to see examples and see what's commonly done. We don't have a lot of experience. We haven't seen very many examples outside of like this graph here that we generated. So definitely let us know if you do have something where you're analyzing multiple trials or you're visualizing in some way, shape, or form. We'd love to see and hear about it, either your idea about the ST or just a single trial as well. That would be very helpful. So great question. I'm going to toggle back to the settings and let's create another graph. So we can keep this first graph if that was instructive and useful for us. Now we can turn on a second graph. So let's just try some more things we can do here. I'm going to take precipitation again, even though we did graph that in the first graph. I'm going to use this again because I'd like to highlight an additional type, a type of type, I guess, in this case, We have the line graph we used last time, but we have a line graph that's a total. And so we would get the cumulative precipitation in this case. So this might be a little easier to visualize the, how much rain we've gotten throughout the season, as opposed to just those spikes where we saw when there was rain that occurred. Maybe we're more interested in how that's accumulated and how much rain we've gotten at certain times of the season. And maybe if we want, we also have the 30-year average for the precipitation at this location. Maybe it would be useful to kind of compare that. Maybe we'll just do the very same, cumulative graphing here, and we can see how did this year stack up compared to the 30-year average. Was it more or less? Maybe we started out pretty wet and then we didn't get much else. We can kind of see what actually took place. And so maybe I'm going to change my axis to total precipitation, would be how I would want to label that graph. So let's say OK. And now we have still that same first graph, but now we have a second visualization here. And you can see now that the line isn't just the spiked occurrence of when precipitation happened, but instead we have the gradual accumulation of our weather, or of our precipitation, excuse me, across the season. And we can also see the 30-year average, which is much more smooth, and looks like we had a fairly wet year this year. If we move the slider, you'll see now that as we change the slider up top, we're actually changing this graph. So if I want to zoom in essentially to just June through August or whatever date range, maybe I only want to zoom between application A and application C. That would be just fine. I'm just kind of lining those up with those dates. And now we'll have the graph just in that date range. So this slider controls both our weather summary of what statistics we can pull, but then also what is graphed here down below. If we really want to compare, in this case, probably not super exciting since we're doing the totals. That's probably more illustrative to see the whole season. But that slider controls both sides. So we can continue to go back and forth here and add more graphs if we'd like. And I've got a couple more examples. If we have time, we can get fancier with things. But I do want to show, once you have the graph, looking like you would like it, if you want to save how you've configured this so you can do the same type of graph with other trials, we do have a graph option set. So very similar to other things in ARM where we save a view or a report set. Let's bundle our selections we've made here into a file that we can load again and again, so we don't have to do the same work again and again. So here I've created quite a few before that I could load. Now that we've set up our own, let me do a save. In this case, I want to do a save as because this is a new graph. I haven't created one yet. So let me save as to give this a name first. And I'm just going to be pretty lame and say this is just our webinar on weather. But certainly you can name it for whatever you'll want to denote and use later. So now we have our option set that we can always reuse in another trial. That can also be used. So if I cancel here and close my graph, when we were first starting this process and we had graph weather data, I had chose to start with a new graph. But if I load a weather graph, that will let me select that weather graph file. WGF is the extension there we just created. And that loads those settings that we had And now we'll draw the graph with the data in this current trial, which of course it looks the same because I didn't change trials. But if we were in a different trial, it would have different data because we really just saved the options that we used to create the graph, but we didn't save the graph itself. So again, that was done on the settings that we're saving the option set here. And that's saving really the options as we've configured it. If you want to save the graph itself, you have a couple of options. So if I like just this graph right here, this cumulative precipitation graph looks just like I'd like it, or maybe, like I said, maybe we zoom in and do completion date to application A, whatever range you would like. Yep, this is what I would like. It'd be really great to put this into a PowerPoint slideshow I'm making right now, or drop into a Word document, or even just in an email. You can just right click on that graph, and if you choose copy, it will just put it onto the clipboard. Essentially kind of like taking a screenshot. So then if you're in a Word document, PowerPoint, email, whatever, you can just paste. Sorry, I did that with my shortcut here. You can just paste, and now you've got this image that you can resize and do whatever you need to with. But that's kind of the quick and fast way to get it out into another program. There is also a save as. So if you want to save this to an image file itself, you can make a bitmap, JPEG, PNG, choose the resolution and create that file. So if you want to be more formal with that, that would be the way to do it. Finally, there is also a print option. So this will print, essentially will create a report for us with all of the graphs that we've defined here, as well as the weather summary. So if I say print, it'll bring the print screen here. And so I can actually preview on the screen to show you what will be included. But it is just essentially the graph that we have, or all of the graphs that we have, and then the weather table summary. Again, for that range that we had selected with the slider. So this would be something that you could print out to send to your printer, or any of these other file types too. So that's kind of the output options here for these graphs once you have them looking the way you would want. All right. Well, that's really all of the features I would say that I wanted to cover with the graphing. As I said, I'll maybe show just a couple of other graphs that I've created before, mostly just playing around with the different things you can do, whether or not they're particularly useful, I don't know. But let's turn on a third graph. And this was one where I was playing around with the temperature. And I'm actually kind of referencing the settings I used before. So I did the max temperature as a bar graph. Well, let's just first show kind of what the bar graph will look like, since we hadn't created one before. So the bar graph is pretty nice instead of the line, to kind of get that shading in essentially. And then if you zoom in, so I'm going to zoom in our range a little bit. It is actually individual bars. Just usually we have such a wide date range that it essentially looks like it's almost just a line filled, colored in. So just depending on how much data, how many ranges you have, it kind of creates just a colored in appearance. But as you zoom in closer, you'll start to see the individual bars separate out. And so what I found with these bars is that as you add more data sources, they get drawn on top. So if I go to settings, and I want to show the minimum temperature as a bar graph, maybe I'll change the label now just to temperature. The color choice is kind of set for us, but it works well because the blue kind of blends into the background and that orange pops out more. So it created a nice range here. It almost looks like two different mountain ranges of the max temp and the min temp. So depending on if you're struggling to make it look quite right, changing the order could help as well. So if I change the min and the max around, we'll see we actually don't even see the minimum at all because the max was chosen second, and so that gets drawn on top of the first layer. So, so we actually don't even see the minimum at all because the maximum is larger and because we chose the bar graph. So the bar is over top of the shorter bars underneath. The line graph, of course, doesn't really matter because they're would just be lines. But the bar graph took a little of playing around a little bit. But if we switch those back, now, knowing the max is taller, that will be in the background, and then the minimum can be in the foreground. And actually, I'm going to take this one step further and do the minimum as the third data series, and then bring in the average temperature. Doesn't really work to try to have a third bar graph in there because something's going to get drawn over the top of if we do that. But if you put in a line in between, oops, I must have, let me go back. I must not have picked the, yeah, I ended up with line total over here. So bar, bar, and then a regular line for the average temperature. Then I ended up with kind of a cool graph here where you have the line in between the maximum and minimum that's shaded in of the average temperature. Again, whether that's useful or not, I don't know, but kind of neat. Just the way this tool has a lot of flexibility as to what data set you choose, and then the order that you choose them in. You can really get clever with some visualizations. I think this scales in pretty well too. So if you zoomed in a little bit for whatever date range, it still looks pretty nice, I think. That line kind of sticks out even more than in that case too. And again, I've kind of stuck just to temperature and precipitation, but really any column of information that you have in your weather table is really up for discussion here on graphing if you would like. So any column that has information can be chosen. And I guess just looking at the different types that we have, the area is probably going to be similar in appearance to that bar graph when we were really zoomed out, but really technically the area is a line graph that's just shaded underneath. So you could kind of do the same trick we did with this data series here when we use the bar graph. You could do something similar with the area. And again, we have the total section for each of these options really. The step and the line and the area has that total. So that will calculate your cumulative information throughout the time. And we've seen the bar, we've seen the line. Scatter graph, I don't know how well that shows up for most of these data points. And I think the spline is pretty much just a line graph, but just smoothed edges. The curves are a little smoothed out. Again, for such a large range, I don't think there's a huge difference. let's compare. Let's maybe just remake this precipitation one and we can see if there's much of a difference. Precipitation, spline, and we'll do precipitation as a line and just kind of compare these two maybe. Oh, we should probably get rid of this other cumulative one if we're going to have a chance at seeing the difference there. So you can tell that it's just a little smoother, but it's pretty much the same as the line graph. And then there is a step. So that's kind of the opposite direction from the spline would be step where it's even more jagged, which might be a better fit for the precipitation perhaps. Let's choose step and just kind of see how that looks. So that really boxes things out, which might be a little more indicative for precipitation. Let's zoom in again just to see how that looks a little closer to really step. Since really precipitation is an event of that day, and there really is no kind of implication of up and down. Maybe that's a better fit for precipitation compared to temperature, where it is always moving up and down. So that's our weather graph. Any other questions? As I mentioned before, definitely if you do currently do any work with weather visualization that's not available in ARM, we'd love to hear those ideas and see if there's additional tools we can create for ARM to do something with the weather data. It's great that we have that repository for all of it, but it's very nice to be able to do something with it. So feel free to send anything to us if there is something that you're doing on your own that is time consuming because you're building it in some other tool. It'd be great to have it in ARM. All right. Well, thanks everyone for joining us. Have a few webinars coming up. Hopefully, maybe we'll be seeing you at some more of them. So thanks everybody.